The Ukrainian wood screw is back with a new and improved version. Originally I had a Tecumseh 10 horse engine down here, and then I put on a lightweight 1/3 horsepower furnace blower motor on here. But I didn't find that adequate, so I wanted to beef up the strength. So I was looking for a 3/4 horse engine, but when I went to buy it, they had a 1 horsepower on for sale at the same price. So I've replaced the 1/3 horsepower motor that was in there with a 1 horsepower electric motor. And the system is set up, and as you can see, it is working. Now, it's working well enough to make this kindling, and all of that kindling. But I've also got a bunch more blocks here that need to be split up at some point in time. But before I do that, instead of having just a single switch here on the power, this motor has accessible windings that this thing can be reversed. Because the problem with this thing, which all along, is that it's not that powerful, and even with a 1 horsepower electric motor, it's going to be better than the 1/3, but it will still jam. So I took a block like that with a big knot in it. I know this is only cedar. And if I put that on there and tried to split it, in all likelihood, it would jam. So what I want to be able to do is, if it does jam, stop it before it jams completely with a switch, and then be able to back it off. And then what you do, because that's a stupid place to put it, you would move the wood over and take off a smaller bite. What I have been doing is using my custom made wrench, and if a block jams, I can put the wrench on here and back it off my hand. And I will never throw this out, but I would like the convenience of a reverse. Sure, if I had a reverse, that would get me out of 90% of my jams. That is today's project, and that is what this video is about, is wiring up this thing for a reverse, and then we'll do a little demonstration, see if I can jam it, and see how well I can get it unjammed by using the reverse. Yes, so we'd like to be able to reverse our motor control, be able to turn it forward, off, and reverse. So this is the manual for the motor that I bought. 1 horsepower. And inside here is the diagram for wiring your motor. And they show high voltage, low voltage. And at first I didn't know what they meant, but then I realized that's for 240, 120. Yeah, so let's concentrate on the low voltage wiring. Now we can't see that very well, so I've taken the liberty to make my own diagram here. And the purpose of this diagram is to show the way it's wired. So on the left is counterclockwise, the right is clockwise. So they have, regardless of whether it's clockwise or counterclockwise, line 1 goes to P1, and P1 being a wire within the motor, and regardless of how it's wired, clockwise or counterclockwise, L2 goes to one of these sets of wires down here. I'm calling L1 live, and I am calling L2 neutral. But what you can see from here, whether it's counterclockwise or clockwise, we have 2 common wires. We have P2 and T3, P2 and T3. And the wire that mixes is T8 or T5. And then down here we have T2, T4, T2, T4, and again the wire that gets switched is T5 and T8. So what we have is 2 commons, P2, T3, T2, T4, and 2 variables, T5 and T8. So all I really need to switch this thing around is a double pole, double throw switch. So this is my drawing of a double pole, double throw switch. So what I have in this over here, so this is the switch. These are the incoming lines. So you got the black, the white, and the ground, which represent live, neutral, and ground. So the ground is going to go directly over and connect to the motor. The live, I've chosen to use a standard household 120 volt one pole switch, and that also is going to go to the motor. And up there, as you can see from that diagram, it is P1. So that's P1, and this is ground. Neither of those need to go through the switch. So what we're going to do is we're going to switch the neutral between the neutral down here between T2 and T4, and we're going to switch T5 and T8. So we've got two commons. So the neutral has to go to one of the commons on the switch. So that's one of the common poles, and the way the double pole, double throw switch would work is these two contacts will close when you throw it one way, and these two contacts will close when you throw it the other way. So in other words, the switch moves like this. Alright, so up at the top, we have, coming out of the motor, we have a set of windings which are common. And they are P2, T3. So that pair of windings goes to the other common pole on the switch. And down at the bottom, we have another pair of common wires that are going to go to here in conjunction with the neutral. And that is T2 and T4. T2, T4. So these are common. And then coming out of the motor, two wires left, T5 and T8. T5 and T8. So it doesn't matter which one goes to where on the switch, but the way they're orientated in the diagram, let's put T5 to this pole and let's put T8 to this pole. So when you switch this way and turn on the live, the motor will run. So in order to reverse the motor, we simply have to run this wire over to here and T8 over to here in a crisscross. So what happens is when the switch throws, P2, P3 will connect to T5 this way, and all of these wires here, the neutral T2 and T4 will connect to T8 when you throw the switch in this direction. And now, if you throw the switch in the other direction, because this wire is crossed, you are also crossing it this way. So you're moving this wire up to here and this wire and T5 down to here. So you're now going to connect T5 to the neutral and T2 and T4, and T8 will connect to P2 and P3, and that will reverse the motor. So I went online to try and buy a double pole, double throw switch, and what I thought maybe I could get a standard house wire switch, and I could use a standard box, and I could put my on-off switch over here, and I could have my double pole, double throw over here. But as it turns out, you can't buy a double pole, double throw standard house wiring type switch. So what I bought is this little gem here. What it is, I'll have to look up the designation, but it's basically called a rotary switch, 3-pole, 3-position rotary switch. So it has a 0, it has a 2, and it has a 1. There's a switch between here and here, and here and here, and here and here, in one direction. And there's a set of switches on the other side between here and here and here and here and here and here, and they're all independent. So schematically, if you can see it, it looks like this. So you got 6 contacts up there for one set of switches and 6 contacts on the bottom for another set of switches. So I've already made up this little diagram, hopefully you can see it. So up here we've got P2 and P3, and down on the bottom we've got T2 and T4. So I've chose to wire them to this switch with the same wire orientation as I did with my double pole double throw switch I'm showing up there. But this is not a double pole double throw switch. It is 2 sets of switches that work in the opposite direction. So what happens is when this thing is at 0, all of these switches are open. When it's set to 1, the top contacts are made. When the switch is set to 2, the bottom contacts are all made. So I think the way to represent this as a switch is they work in opposite directions. So I will draw the switch contacts this way on one switch, and I will draw the switch contacts this way on the other. So when you turn them, when you rotate that dial, these switches turn in opposite directions. So if you turn it one way, these switches will be made and these will be out. You turn it the other way, these switches contacts will come up and those will be out of the way. I have chosen to simply take one pole on the top switch and connect that to P2 and P3. But because you have to switch P2 and P3 as well as T2 and T5, that common has to come down onto the other switch as well. The other common is T2 and T4, so I've chosen the bottom pole for T2 and T4. So I've then chosen to take T5, which is a separate wire, and I will run it to the top pole on switch number 1. So this is T5, and it will run in through here and connect to the top. I then arbitrarily decided to take T8 and connect it to the bottom pole. So right here, when this switch throws, T5 will be connected to P2 and P3. And this switch is open. But in order to reverse it, you have to get T5 connected to T2 and T4. So we take the common point, take this point which is common to T5, and we run that down to the switch side, so that when we throw the switch in the other direction, T5 will go through here and it will connect to P2 or T2 and T4 and no longer connect to P2 and P3, because this switch is open, this switch will be closed. And then we do the same with T8. We bring T8 into this side of the switch and we link it to the top pole on the other switch. And again, what happens is when T8 is connected here and this switch is thrown, T8 connects to T2 and T4. And then when we throw the switch in the other direction, T8 is on this switch bank and it will connect to P2 and P3. And that's how I'm going to reverse the motor. I could bring the live into here and into here and tie these two outputs together, so no matter which way you turn the switch, you will have the live connected, and when it's in the 0 position it would break. So this switch here could be replaced. I don't really need it. I could do everything with this, but made in China, $25 drum switch that at this point in time I gotta hook it up and test it before I'm really comfortable that this thing is actually going to work all that well. Nice to have a standard house switch that I know 100% for sure works. I can interrupt the power easily at any time and then I can simply turn the direction with the rotary switch, and then turn the live back on. That's what I've chosen to do. Okay, continuing with this motor reversal. So this is the power switch. So the black wire is just going to carry through down to the motor. The ground wires are terminated in this second box, and the neutral, as shown in this schematic, has to go to one pole of the switch. So what I need is I need 4 wires to travel back. So this is the motor over here in the schematic. Be over here. So I need 1, 2, 3, 4 wires to come back to my switch. And I pre-wired the commons on there. I just need to add those 4 wires. So the neutral that's in here, which goes down to the motor, is going to be one of them, because the neutral will be fed into the switch. Okay, so everything's wired up. Here's the switch, the live. The live carries through, the ground terminates, and we've got 4 wires coming back to this control switch. 2 whites, the black and the green. So I chose to take 1 white from there and tie it to the neutral, use it to tie T2 and T4 into the switch, and then I took the other white and I've tied P2 and P3. So that's these 2 wires here on the top and the bottom of the switch. And then T5 and T8 are represented by the green and the black. And you can see where they come down and they crisscross. So let's turn it this way, which would normally be forward. Let's see what happens. Okay. So that works. Turn it off. Turn the switch the other way. And turn it on. And it goes the other way. I don't like the way my switches here are working. This switch will cut the power at this switch, but if I leave the power on, this switch, when it's in the off position, is not off because the power is bypassing it. So if I want to change directions, I have to turn the power off here to do that. So what I'm going to do, I want to leave this switch in because it offers me a level of safety. I can always cut the power right here. But I want to also cut the power in here so that I can go forward, stop, reverse. And the motor has to stop. You can't change the winding direction while the motor is still turning. You could damage the motor, and I don't want to do that. So let's make the change. And you probably remember this little diagram here. that's my setup, my switch. So I've redrawn it a little bit bigger here so that I can talk about what I'm going to do. So what I have is I have a household switch here which cuts the mains, but from that point it goes direct to the motor, and that's represented by this switch here. And this is my 3-position, 3-pole drum switch, which handles all the switching and motor control, which is here, and I've got it out because I'm ready to rewire it. So what I need to do is, instead of having this wire go direct to the motor, I need to break this contact. I want to keep this switch, and as you see, I've got 2 switches here that aren't being used, 1 on each bank of the motor. So what I need to do is take this over to the live, bring the live into here, and because the way these switches work, this switch is independent of this switch bank, I need to do the same thing I've done on this side of the switch with the other commons. I need to bring the live down to here as well. So we need to bring the live up to there. So we got the live coming into both sides of the switch, and it has to be able to get out both sides. So once again, I'm going to have to take the center commons that are unused here, bring them together on this side, and then take from this point and go back up to here and into the motor. So this whole wire has got to go. So that'll allow me to have an emergency shut-off power switch here, and the rotary switch should interrupt the power, select forward, off, and reverse. So let's rewire that and give it a test. Power entry plugged into the power bar. Switch is off, nothing happens. This switch is off, nothing happens. I'll turn the switch on, nothing happens. I'll turn the switch off and set it to forward, and it should go forward. There we go. Doing it as before. Turn it this way, turn the switch on, and it goes in the other direction. What we really want is to be able to break it. That's what we want. So this switch is represented here in the schematic, and this switch is represented by this switch. So I can interrupt the power, and nothing will happen here. Turn the power on, it's interrupted there. Turn it to the right. Goes forward. Clockwise. Turn it off. Counterclockwise. That's what I was looking for. So now that I see how it works, I was thinking of replacing this, but it seems to work fine for the time being. Going to stay that way. This switch here, which turns the power off and on no matter where this switch is. Ideally this switch should be down on the floor, and it should be a pedal switch, because you should be down here on the floor and you can run it with a pedal, because you're busy here with your hands hanging on to a block of wood, and if anything happens, be nice to just either step on the switch to cut the power or take your foot off, whatever is available out there. So in all likelihood, someday I'll replace that switch with a foot pedal. But for now, let's see if we can split a little bit of kindling and see if we can jam this thing and then back it off with the motor instead of having to use a manual wrench. So let's give that a try. Good. Should be able to jam it in this thing. Yeah. Go right through. Now what do you do, eh? Full block. I'm sure we can jam it in this sucker. I'm going to get ready with the power switch. Can't jam it now. See if I can jam it on this knot right there. There we go. Now, if you throw it the other way, will it spin it out? No. Jammed is jammed. But admittedly, I did let it go in awfully far. Okay, so we've backed it off a little bit. See if we can back it off the rest of the way. So, it's an improvement. I don't mind if the motor slips actually, because that gives me, prevents things from being damaged. I'm gonna back it off. Better than having to do it all by hand. I guess we'll just make some kindling.